Hello, this is Justin Kaltenbach. I am the CIO for Health IT Squared, and this is part 4 of our OHMPI series for Oracle Healthcare Master Person Index. In this presentation, we're going to actually continue with the software demonstrations, and we're going to look at some of the technical aspects of OHMPI. So we're going to look at how we interact with the product via web services. We're going to look at the underlying database structure, get a feel of what's behind the scenes, and we're also going to take a quick look at a Java messaging service that is part of the product, and that's how we get outbound messages from OHMPI when different events occur, like a update, a merge, an unmerge, add, whatever it may be. So just a quick background, Health IT Squared is an Oracle Gold partner, and we are one of the few specialists in healthcare for Oracle. We've got a bit of background with OHMPI. We've got at least 10 plus years experience having worked with it, while many of our folks were employees at Sun Microsystems and Oracle where the product existed, and ongoing today where we continue to service and support OHMPI as well as several of the other products around healthcare information exchange. So we thank you for joining, and I'll go ahead and get started. I'm going to toggle my window here just to jump to my presentation or my demonstration session, which is a VM running locally on my machine. And just to pull up, just as a quick level set, I've got my browser window here, and I'm logged into Master Index Data Manager, and you'll probably remember I did a search in presentation 2 on Morishita, and you'll see these same search results that we saw before. So I'm just quickly using the web UI to bring up some data as an example for what we're going to see through some of the different technical ways to find this information within OHMPI. Now, typically when OHMPI is implemented, we interact with it in a couple of different ways. One is through either a Java API call, and that's just a native Java API. So your integration engine a lot of times would be calling these APIs as part of a flow or a process where messages are being moved in between systems, like from registration to other ancillary departmental systems. Or in the case of an HIE, we've got ADT or registration style messages coming from the different participants feeding into OHMPI to create that unique identification across the health information exchange. So just depending on the use case is where the product will fit in, but needless to say, the way that we call it is essentially the same. And so to make things simple and make it understandable, we're going to call the services as a web service, in fact, not a Java API. But as far as how the APIs look and the fields and things like that, the classes and libraries that you would see, the look and feel is very much the same. So there's not too big of a difference in how we call or what we call, whether it be Java or a web service. But really, it's just a different technology approach for each of those. So I'm going to load up a tool here called SOAP UI, which is a very simple to use web service and SOAP messaging test utility. And I've got a few of the different APIs queued up, as well as you can see the overall list of APIs and web services that are published by OHMPI. And so, for example, the first couple ones here are for activate record, deactivate record, execute match, and execute match update are really the primary APIs that we would call during some sort of registration process. Again, whether that be in a hospital setting or health information exchange. We're going to look at some of these called the Get Enterprise ID and Get EU ID, Get LIDs, or local IDs. All of those are ones that we would call for identification purposes. And then we'll just do a blanket search. So we're going to provide a query to OHMPI and look at the results that come back. So I'm going to open up that search window first, and you can see from earlier I've got some data that was in there. I'm going to maybe just delete that out quick. Let's see if I can clear that out. Yeah, it won't let me. That's okay. So that's fine. And on On the left-hand side is the input of this particular search. It's XML based, as I noted. We're doing a web service call. I've narrowed down my list here from a large set of fields that come standard when we do a query. If I just hit new request and pull that up, excuse me, we see an empty example of a query. So what it does by default in this utility, which is kind of nice, is it pre-populates all of the fields that are part of that XML query. And you can see each one there with a question mark in there. So we can fill it in if we want, or just delete it if we don't want it. And that's what I've done in the other example that is already filled out. So I've narrowed it down to the fields that I want to use. I'm providing an address, a home address, line 1, a date of birth, first name, gender, last name, and a social security number. And again, social is not necessarily required, but it is in my particular project, and that's purely an implementation option. So I'm going to submit this request. I'm going to execute it, and you can see it's processing. It actually responded back and completed. So now the results are displayed on the right, and they did refresh on my pane here. So the results that come back, again, an XML structure, and each of these results is going to essentially have a nest of information. It begins, if I just collapse some of these, maybe to make it a little simpler to read, you'll see that there's a looping element here, which is search patient result. And I'm just going to continue to collapse it. I think there's about 11 that are supposed to come back, maybe a few more, because I've got a little bit different criteria. Anyways, I think you get the point that there's a repeating piece here. So let's break down what's in search patient result. First off, every result that comes back has a score. This is what came out of the matching algorithms. It also comes back with the enterprise universal ID number. Beyond that is a patient tag, which I have collapsed. I will now expand that. And that patient consists of the data that's on file in that single best record in this case. So we can see the patient address and a breakdown of the details there. You'll notice that address line 1, to make it nice and easy to read out, is broken apart into several subcomponents, including the street name, the number, a phonetic value of it, and even the street type, which is, in this case, street. The rest of these pretty self-explanatory. We have an alias set of fields in these alias element tags, George Morishita, as well as the phoneticized names, and then even an alias where we've encountered the name backwards with Morishita as the first name and George as the last name. We then get to some of the other standard fields that you'd expect, like date of birth and an ethnicity code, as well as a marital status. M stands for married in our system. Race, W, is white. Religion, BU, is Buddhist. And you can see also a social in there. So the response came back rather quickly, and if I look through some of these other examples, I'm just going to scroll up to collapse this one. We can see a different record that came back, and this is a lower score. It's in the negative, which means it's not a very good match. But because I've set up my demonstration system in such a way to give us some different examples, I've got some very relaxed rules for how my results come back. All right, so again, a few examples, and if I just scroll to the bottom, let's see if there's any other data to point out here. That's really it, but very simple, straightforward web service call. The endpoint is just published right there on my web server, my application server. In this case, it's Glassfish, so you can see what the URL looks like there. And earlier, I just imported the WSDL from that WSDL, or URL endpoint, I should say. All right, so that was a very simple look at how we would do a search. Let's look at some of these other ones here. So let's say I've got an enterprise ID number, and I want to get the local IDs back for that particular ID. So a very simple call, we just use the web service get lids, or local IDs. The input I provide is an enterprise ID number, and when I execute that, you'll see the response time, 23 milliseconds, pretty quick. is an XML structure with the responding local IDs and system codes that correspond. Whenever we talk about local ID numbers, it's always paired with a system code. So every local ID that comes back has to come with a system code as well. So we can see that for this enterprise ID number, which actually ties to our favorite patient there, George Morishita, it comes back with a set here, and in this case there are two local IDs, meaning this patient has record on two source systems. One is PCC, and that local ID starts with 541. The other is Cerner, and it starts with 998. And you can always think of those local IDs as usually the medical record numbers from those systems. All right, so we can do the flip side of that query where we provide a local ID and a system code, and we want to get back the enterprise ID number. And so that is the get EUID call. Just move these windows over here so we get a quick view. So like I noted, we provide the system code, which in this case is Cerner or PCC, my demo environment, and I also provide that local ID number. And I execute that, I get a response back. And rather simply, I have the enterprise ID number. So we're not really seeing the complete record yet. We've only seen the single best record when we did that search. And there's obviously a lot more data in the system. And we don't want to have to query every record multiple times just to get a complete picture, such as if we had an enterprise ID and we want to know what all of those system level records look like. But we can actually call a get enterprise record type of function. And if I just use this as an example here, we have get enterprise record by local ID or by enterprise ID. So I'm using the local ID version, which is calling using a Cerner code and a medical record number off Cerner. And then the response that comes back includes the entire enterprise record. So it includes the enterprise ID number as well as it includes the single best record tied to it. And if you go even below that, we can see that we've also got data from our different source systems in here tied in, and from there we can kind of get a feel of what the data is from those particular source systems. So if you remember back again, the breakdown that we have in our system is there's an enterprise record which comprises of a single best record or a golden view, as well as then the source system records. And so those source system records are what came from our particular sources, whereas the single best record is a hybrid of data from the source systems. And we say it's a hybrid because whenever there's a conflict, there are rules that determine what value we use from what source system in the event of a conflict. So when we want to represent patient Morishita as one single line item in the search results, we need that single best record concept. If we didn't have it, we would have to show all of the different records that exist across all the different systems. And we'd be in the same place we were before implementing in the MPI. We'd have 10 or possibly more different ways of representing the same person. So that single best record is a nice concept for creating one single view or one single representation for every person in our system. So again, very straightforward for accessing the web services in here. In fact, if I go to try and show, let's see if I can pull up properties really quickly on this. It'll give you an example of where we set some of the parameters. So this is just a link to that WSDL. If I click on it, it'll launch the browser, and you'll see the web service definition as it's deployed from the application server. All right, there's that endpoint there. Okay, so minimize that, and I think we're done in SOAP UI for now. So that's a quick look at the web services. So underneath OHMPI, we persist our data in an Oracle database in this case. The product does support Oracle, MySQL, and Microsoft SQL. So clients out there do have options for what they would like to implement. It really boils down to a set of tables that you see on the left-hand side here There's maybe 20 or so listed on my screen, and that's basically it. So one of the nice things about OHMPI is the simplicity of its structure and its underlying database. I think one of the differentiators with OHMPI that some of the other products on the market may not have is how transparent the data is within the database. And for our clients, that's a big bonus, because it means we enable clients and even partners to go into the product, make changes, view the data, and even run and build custom reports if they wanted to. It's a very open structure, whereas some of the other products on the market aren't as open, and you're very limited in what you can do and how you can manage and operate the software on your own. You have a vendor dependency in those cases, whereas OHMPI is quite the opposite. You can be very self-sufficient. So I've opened up a table here, patient single best record, and this is sort of that root level of data on a patient that we keep. You can see the breakdown of the fields, and there's an enterprise ID field as well as a patient ID there, which is more for internal tracking. First name standardized, first name phoneticized. So the standardized is using those tables that are compiled in the project to create a standardized form of the name. So Tina is the name that came from the source system, and we say the standardized version is Christine. You could also have Christy or Crystal or different variants there. Those would root back to the standardized name of Christine. We also have the phoneticized value in here, which is a codified data. If I scroll to the right, we can look at the last name fields. McFadden, a standardized version if there is one, as well as the phoneticized. And then we get to some of the other fields that we saw, like a social ID, date of birth, gender, and so on down the line. So these are all single values that don't repeat. Now we can get into some examples where we do have repeating elements like address, and if I just pull up this table, you can see the structure here. And again, keep in mind that patients can have multiple addresses, so that's why we have a separate table to keep addresses. It's basically just standard referential integrity when you look at database structures. And all the fields you could expect, several fields for address line 1, as we saw in our query result there, because the system is automatically breaking apart that address and putting it in these fields. And it just makes the internal mechanisms for how we query the data and understand the variations there a lot simpler. All right, there's a very straightforward table called system object. And system object just has references to the system codes themselves as well as the local IDs. So there's kind of a pairing there that you see. And if I go to, I think it's enterprise. My phone's ringing. If I go to enterprise here, we can see where the representation is and linkages of an enterprise ID back to the local IDs and system codes. So there may be multiple records of system code and local ID pairs that tie back to a particular enterprise ID. So let me maybe see if I can scroll and see really quick an example of where we've got some duplicates. And you know what I'm going to do? I'm actually going to switch back to SOAP UI and pull up one of my enterprise IDs here. And I just want to do a query in the database. And so if I look for filter by an enterprise ID, I see there's two records that share the same enterprise ID. It's George Marshita. And these are the system codes and local IDs that come back in response to that. All right. So the rest of these tables all tie to some of the different looping elements like address and alias and comments and auxiliary ID, existing conditions, insurance, the patient itself, the phone number. All those tie back to looping and repeating. And then there's some common tables like application in here, which you see is very simple, just a single record. And application is because we can have a multi-tenancy deployment of OHMPI. meaning on the same application server, multiple implementations of OHMPI running and running independently. Tables like assumed match handle the transactions that were flagged for an assumed match, meaning they were a pair flagged for being above the high threshold. They're automatically linked together, but they're flagged, so we can review them if we want. Whereas potential duplicate records are sitting in our queue awaiting for a human to review to decide should they be linked together or left as separate. So you can see here. And then the transaction log, which we saw in our earlier presentations. Transaction log basically records every snapshot and change that takes place to the data, so there is always a historical view available for us when we look at the data. All right. Well, that's it from the database perspective. I will move on to one last particular piece, which is the JMS messaging. So on our application server exists a JMS queue, or I should say topic in this case, and what's happening in the system is anytime there's an add, an update, a merge, an unmerge, an activation, a deactivation, basically any type of transaction that takes place on our data or our records, an outbound message is pushed into a JMS topic. And what that is a descriptor or an XML-based message which shows the content of what changed and the context. So meaning what function happened, was it an add or an update, and what the data was that changed. So this is very useful if we want to feed that information to downstream systems so they can be aware of changes that have taken place in OHMPI. So I'm using, again, another just simple tool that subscribes to that JMS topic on our application server, and you can see it highlighted here as OHMPI patient member topic. And even on the right, you can see there's already some sample messages in there. So from one of my earlier demonstrations, these have queued up. I'll see that there's 4 of them there right now. If I wanted to, go and modify something, I could create an additional one. But let's take a look at some of these and view the payload of that message. So the top part is going to show some header data, and that's fine. I'm going to maybe pull this as a pop-up to get a little more. But basically, this outbound message that was created describes the event that took place and helps us view the data and be familiar with what also is going on in there. So if I look at this particular message, it gives me transaction ID numbers. As you see, it's XML based. It's telling me what the enterprise universal ID was here, as well as down below in different parts of this structure, it gives me some of the different objects, such as what the local system IDs were. So we see one here for PCC as well as one for CMH. All right. So I'm going to scroll a little bit to the right and look at some of the record information on the top here, and I see what the create function was here, and it was an add, and I see the date and time that it took place. I see the user that did it, and so by sort of scrolling through this, I can see that there was an add that happened on this system, and a record was added or added part of a record to another enterprise ID number in here. So let me jump through another one, and I believe one of my examples had a merge that took place. So I want to try and see if I can spot that really quickly. And that's an add. Where's my merge? Look here. It may be the first one. And if I don't have it in here, I just may not have recorded a merge, so that's okay. All right, so it looks like this was also an add. Maybe it was the second one. It was a merge. No, this was also an add as well. So that's okay. I just have adds in this example, and that's perfectly fine. So, again, at a high level, the purpose of this particular function for outputting messages to JMS is so we can see what actions have taken place in our system and against the data. And in a lot of cases, we've got downstream systems that are looking for information and are desiring updates when they take place. So if we have an environment such as a health information exchange where things are very dynamic, let's say there's a new address that's registered to a patient, using this feature of the JMS outbound topic, we can receive messages back into the HIE and broadcast them to participants to say, hey, there's a new address on file. And it's really up to those participants at that point to decide whether or not they want to do something with that update, such as put in a new address or update an address. Again, by pushing out these messages, we're not forcing updates into any system. We're not forcing changes of data into any system. It just presents the option to do so shall a client or participant desire to do that. So that's the last piece there. All right, so those are really the three key technical pieces I wanted to show today. And just as a quick recap, we looked at the database, we looked at the underlying tables in OHMPI and some of the data that's in them. We looked at how to call OHMPI from a web service standpoint and what the results look like when we do that. And we got to see some different examples of the APIs that are exposed in OHMPI. And lastly, we looked at the JMS queue or topic to which OHMPI publishes any events that take place in the system. So we can disseminate that data to downstream systems if we'd like to. So just a quick recap on Health IT Squared and OHMPI. Health IT Squared is a services and software company. We are an Oracle Gold partner, so a lot of what we do focuses on Oracle technologies, and we've been around a variety of Oracle technologies for quite some time. If you just see on the slide that we've got a pretty broad spectrum of things that we do based on the other clients that we support today, both from a software standpoint as well as from a services standpoint. So if you have any questions on OHMPI or anything else related to your healthcare infrastructure, I encourage you to reach out at any time. I've got my contact info on the screen as you see here, and we're always happy to answer questions, as well as quite simple for us to set up even a live demonstration of the product to show you around and answer any questions that you may have within there. So I thank you for your time, and